So, good afternoon or good day, everyone, and welcome to the last session of UP Manila SILab's webinar series, IOL 101 Leg 2. I am Gabi Velasquez, SILab's Communication Officer, and I'll be facilitating today's webinar session. Okay. So, as a standards and interoperability lab here in the Philippines, we envision achieving universal health coverage through digital health capacity building, data portability, and appropriate use of health technology, of course, with the help of health data governance and ethical health data management. So, just a quick recap of our previous sessions. So, in the first leg, we actually learned about the health data governance, the WHO SMART guidelines, the open health information exchange architecture, the role of standards terminology in interoperability, how to set up your very first Happy Fire server, and how to create Fire implementation guides. Next, in the second leg, for the quarter 3 to 4 of 2024, we learned about the Philippine digital health strategy, the benefits and limitations of terminology services, as well as the intro to the FIRE or the Fast Healthcare Interoperability Resources. So we learned about the FIRE manifesto, its specifications, and the challenges. So today we will learn about the basics of Open Health Stack with a special guest, of course, an international expert from Google Health. And once again, thank you so much for the support. We really appreciate you joining our webinar series, and we hope you guys will learn a lot from our session today. All right. So now may I introduce our speaker for this session of IOL 101. I hope you guys are warmed up already. Okay, so our speaker, a global health technologist, a software engineer, social entrepreneur, clinical doctor, and a public health practitioner with broad experience across product development, clinical medicine, implementation science, health informatics, and digital health. Dr. Fred is passionate about harnessing technology to improve access to quality healthcare for all. He has been actively pursuing this since the very early days of telemedicine, way back when a 56K modem of internet connection is still a thing. So I'm not sure if you guys had that before. Anyway, he has been working at the intersection of health and technology ever since. In 2018, Dr. Fred landed his dream job at Google, working within the Health AI research team. And currently, he is the product lead for Open Health Stack, a suite of open source components designed to make it easier for developers everywhere to build next generation digital health solutions using the HL7 Fire and the full stack approach. And he couldn't be more excited about the opportunities for the technology to transform access to care everywhere. All right. So without any further ado, to present the basics and introduction of Open Health Stack, let us virtually welcome Dr. Fred Hersch. Dr. Fred, I give you the floor. So let me just
Right.
stop sharing my screen so you can share yours.
Let's see if this works. Thank you for that warm introduction.
Yes,
Hi,
see
everyone.
your screen
And
here.
I'm glad you filled out the form, the survey, because I was going to ask who knew about Open Health Stack beforehand. So now I have the answer to that. But anyway, that was a great warm up, great set of icebreakers. And I'm glad that everybody is 4.7 on the excited scale for today's talk, and looking forward to sharing with you about our work at Google Health on Open Health Stack, and how we see Open Health Stack as really helping to accelerate the development of next-gen digital health solutions on FHIR. So I think we'll take questions at the end. Please feel free to put them in the chat. If anybody has any burning questions, please reach out or just jump in. Okay, great. Let's see how this goes. Okay, so I mean, just to set the context, I think most people here would be very familiar with this, but in terms of the problem that we're trying to address is really this challenge of access to quality healthcare. So over half of the world, as we know, lacks access to essential healthcare services. It's not just about access, it's about quality. So 9 million preventable deaths annually occur as a result of both lack of access and quality. And actually, if we look at the data, about 60% of those are actually due to poor quality care, so not getting access to the right care at the right time, as defined by things like evidence-based best practices and guidelines that exist. And this mostly impacts communities in under-resourced settings, and those are vast majority of those are in low to middle income countries, but there are certainly pockets of kind of under-resourced settings around the world. And we're all here today very much because we believe that digital health solutions and AI really has the potential to be a vector for addressing this issue of bringing quality healthcare to everyone at scale. And this map that you can see there, that's really like the footprint where there's very large penetration, for example, of Android throughout the world. But we know that there are challenges, right? So there has been to date, well, up until recently, I suppose, a lack of standards, especially for building mobile-based digital health solutions, together with a bit of a program-centric approach where we fund, this program and that program and the other, and we tend to kind of build the same technology but for specific programs. We've kind of led to a lot of fragmentation and silos of data. It makes it very difficult to then kind of exchange that data. We know from our colleagues at the World Health Organization and our partners there that, evidence-based guidelines, when developers particularly try to translate these into digital protocols, they often get lost in translation, and this contributes to that poor quality of care. And we also believe that poor design and usability plays a role in constraining the adoption of digital tools and hampering their ability to scale sustainably. So basically, if we boil it all down, today, building interoperable digital health solutions that can really address this quality of care is too expensive. It is possible, one can build integrations between lots of different systems and others, but we know that it's not very sustainable. And interoperability, as you've all learned throughout this program, is really kind of essential for achieving this quality person-centered care, right? And different groups over the last 5 years or more have really been calling for interoperability because it can help to enable that person-centric care, and it's interoperability based on open standards and open architectures that is being really kind of widely endorsed today. And that last piece there, the academic commentary on the full stack remedy for digital global health, that was a piece that we collaborated with WHO and community of partners to publish at the end of last year. And that really speaks to this kind of full stack approach. And the full stack approach is this idea of open standards, open technologies, open architectures, and open content. And that it's the convergence of these four factors that really kind of is setting us on a path to being able to achieve this person-centric care that we hope to realize together. I'd encourage people to take a look at that. And when we talk about interoperability today, and particularly open standards, we're talking really about HL7 FHIR. I think you've all covered this in previous sessions, and maybe for those that are joining for the first time, it might be worth reviewing some of those. But really, HL7 FHIR is, I suppose, unique in a few ways. And first of all, it's an open specification, so there's no fees involved in using this standard, as there are with others, and historically there have been. And it's very much been designed to address some of these problems of how do we more effectively exchange data. So it's designed to really try to tackle this interoperability problem. But beyond that, what's really appealing about FHIR is that it brings healthcare technology into the modern web development era. So it has RESTful APIs. You use familiar things like JSON, and there's a bunch of different tooling around that you can use to build digital health solutions on FHIR. And it has this very powerful model, the R for FHIR. So it stands for Fast Healthcare Interoperability Resources. The resources, kind of define, if you like, the data, like how you might model different problems within the healthcare domain. And it's extendable as well. And really, what's important about FHIR is we're really trying to promote syntactic and semantic interoperability. So syntactic meaning that we represent things using the same syntax, and we use terminologies. So the semantic part is we use terminologies and coding systems to ensure that we're speaking the same language, right? When I say diabetes as code X12398, another system can understand that because it's using a terminology it's using from a specific code system. And it's the combination of these two things that's really essential to getting to that person-centric care. But whilst it's kind of easy to get started with, and it is relatively easy to pick up and learn and to start to use, it can be challenging, working with any new standard, right? And so this is really the problem that our team was looking at when we were first kind of saying, well, at Google, we're big supporters of standards. A lot of the standards like FHIR have really driven a lot of innovation within some of our healthcare work. And so we were asking ourselves, how can we reduce the technical complexity of working with standards and through that process, lower the barrier to entry for developers everywhere, right? So today, what we see is that there's a lot of time spent maintaining things, kind of below the surface. If you think about the iceberg, right? There's all this, custom code and different components that lots of people are supporting and having to maintain, and it takes a lot of time and energy, and I suppose sucks time and energy from trying to learn and adopt new standards. So what if we could provide more like enabling infrastructure, right, that would address a lot of those things that are kind of underneath the surface, and make it easier to build using standards, right? So how could that kind of promote adoption of standards, promote the development of more interoperable solutions, and really free up time also for local innovation, right? So for people who are closer to the problem to be helping to solve that problem. And that's really what Open Health Stack is. So the mission of our team is around accelerating the development of these so-called next-gen solutions. And by next-gen, we mean they promote this idea of person-centric care, i.e. data is able to flow and follows the person, so that a health worker has access to the right information to make a decision at the right time about that person's care, right? And that ties into the data-driven aspect of things as well. So can we provide decision support and enable that at the point of care? Can we make it easier to also generate insights from data faster, such that they can be used to guide decision making, and really kind of promote this idea of a marketplace for innovation? And this touches on a couple of things. One is by lowering that barrier to entry, by leveling the playing field, so to speak, can we stimulate more innovation? So enable developers, technologists, solutionists to kind of move further up the value chain, if you like, instead of everybody focusing on the things underneath the surface. We can build more value adding capabilities and features above the surface. But can we also make it easier to bring novel capabilities and newer capabilities like AI and others to kind of achieve, in the future, really kind of high quality AI powered healthcare. And that's really what we're trying to do. And so in March of last year, so just I suppose 18 months or so ago, we launched Open Health Stack. These are digital public goods. So these are all open source components that are designed to help developers to build these next generation healthcare apps faster. And these are things like, on the mobile side, we'll go into these in a bit more detail, but it's really being able to build, Fire native apps on Android, being able to ensure that you're preserving security and privacy when building digital health solutions, and components to make it easier to generate those insights from data, trusted insights from data, to drive better decision making. And these components, whilst they all, they can be used in any context, they've been specifically designed to meet some of the unique constraints, if you like, and the unique needs of low resource settings. So for example, being able to sync data from a Fire server down to your device and take that fully offline and then build rich workflows and rich capabilities on top of that. Similarly, on the server side, all of our components are designed to be able to be deployed into any kind of data center, right? So it doesn't have to be the cloud. It can be the cloud, but you can also deploy these into more local data centers or into your own environments. Okay, so I'm just going to spend a little bit of time just quickly stepping through each of these components. And for those that are thinking about joining the boot camp in February, these are the things that we'll go through in much more detail and actually get some experience building with these. So the Android Fire SDK is really what it says on the box. It's a software development kit, makes it possible to really build Fire-based offline capable apps for Android. Right, so this is a set of libraries that makes it really easier to work with Fire. At the moment, it supports Fire R4. And it's kind of like, some people might be familiar with the ODK, which is Open Data Kit, which is a very flexible standard for defining forms and then being able to generate UIs from that very, very quickly. So it's a little bit like that, but for Fire. So it really leverages the Fire specification, things like the structured data capture library, specification and others. And so it implements that. So you can take a questionnaire, which is the way that you would define like a survey, if you like, in Fire, and then load that into an application. And if it's using the structured data capture library, it'll automatically generate those UI widgets and things and enforce all of the constraints and validations and all of the rules that Fire allows you to implement. You can also extend it with advanced capabilities like FirePath and CQL as well. It also has libraries to allow you to deploy Fire-based apps, so as implementation guides, and you might have covered some of that in previous, but when you package up a Fire application, you're usually packaging it up as an implementation guide. So the Android Fire SDK allows you to work with those resources more efficiently and then make them available to your application, and has some very advanced features around CQL, which is another standard from HL7. It's clinical quality language. And this is really used for powering decision support on the device. And this is key to like some of the WHO SMART guidelines content. So the Android Fire SDK is made up of these like 4 different libraries. You have the structured data capture library, as I mentioned, which is about working with those forms and being able to generate UIs very quickly. The Fire engine promotes syncing of data, offline storage, and then a set of data access APIs for working with that data. So kind of CRUD capabilities as well as on-device searching. The Knowledge Manager library is a specific library that helps you to bring some of the what we call definitional artifacts, so like your questionnaires, but also things like your value sets, all those kind of complex library resources like your CQL libraries. And so it actually stores and manages these separately from the patient data that you might be storing in your Fire engine database. And then lastly, the workflow library, and this has some advanced capabilities for being able to execute some of those CQL operations and generate care plans, and makes it easier to work with kind of some workflow patterns in Fire. These are kind of quite advanced. And just to highlight that the way the Android Fire SDK is designed, it's a software development kit, right? So you can see some of the libraries, like the SDC library, can be used in a standalone mode. Some of the other libraries have dependencies on each other, but there's always room to be able to add your application UI and custom business logic, right? So you can really you use it to leverage the capabilities, those things kind of underneath the surface in that diagram, but you're able to build additional features around that and really kind of customize and tailor the application to your specific needs. Within the Android Fire SDK, and I'll show you where you can get access to all of this, but we have some demo apps that you can go and, if you clone the repository, you can build these yourselves. So there's a demo Fire engine app that shows you some of the kinds of workflows that you can generate. There's the SDC catalog app. This is a lovely little app that shows you all the UI widgets and some of the patterns that you can automatically generate by using the SDC library. And now we have a new workflow demo app that kind of takes you through some of the workflow patterns and shows you how it implements those. Great. So the second component, now we're moving to the server side, is what we call the Fire Info Gateway. And this is really about helping you or your developers, your development team, to make sure that you're enforcing the access control policies and things on top of the Fire data that's being utilized within your system. So this is a pretty technical component. It's something that is a bit of a hidden problem for many groups, and it's something that kind of comes up, kind of a little bit later on in your development journey. And what we're really trying to do here is to provide a Fire server agnostic service that basically can sit in front of any kind of Fire server that has an extendable architecture, meaning that it's got this kind of plug-in or pluggable component. So you can define, how you want to implement these kind of the enforcing of these access controls, depending on what your organizational policies are. Right? It also provides some out-of-the-box features for being able to, disable or enable certain capabilities that the Fire Search API. Fire Search API is very, very powerful. It has some things like some joins that sometimes you want to disable those because people can potentially get access to data that they shouldn't be getting access to. And it's also very effective for being able to bring Smart on Fire support into your applications. And these are additional aspects of the Fire specification that you'll learn about over time. When it's paired together with an application that uses the Android Fire SDK, it can actually facilitate also more efficient sync operations. Okay, and then lastly is our kind of components on the Fire analytics side. So we call this Fire data pipes, and this is really about making it easier to transform data to be able to then query that using common tools like SQL, or common languages like SQL, or visualization packages, for example, like Apache Superset or things like this, right? So Fire data, by its nature, is heavily nested. It's like a document, right? Which is great for capturing that rich information for a patient encounter or others, but it makes it a bit more challenging, very challenging to run traditional analytics, if you like, on top of that. And so what Fire data pipes and as part of this Fire analytics components provides is initially a set of ETL pipelines, so extraction, transform, load, that basically transforms data from a Fire source into a SQL queryable Parquet format, right? And it uses an SQL, kind of a standards-based projection of that to represent that data in a schema that's a kind of common schema, if you like. We use Parquet because we want this to be horizontally scalable, or we use Apache Beam on the pipelines because we want it to be horizontally scalable, and then we use a Parquet, which is a columnar format, because as your data scales, you want more efficient ways of being able to query that data. So it's much faster than, I suppose, traditional kind of row-based relational systems. On top of that, we then make it easier to kind of apply views to that data. So I want to take, let's say I've got very wide, format for each of my resources. I want to constrain that down because I just want to query a few different fields for my dashboards or something. So you can apply this in the view layer, and there are different ways that you can do that, including with support for a new standard, which is called the SQL on Fire V2 standard. So that's where your views are actually defined as view definition resources. So basically with Fire data pipes, you can really, very easily set up data pipelines to transform this, and then be able to use that data either for things like powering dashboards, or let's say you have other, advanced data analytics, data science, extracting features from machine learning, those types of use cases. Just going to skip past this. And as we'll talk about, I'll point you in the direction, but this is a common type of use case that people want to understand. Okay, well, I want to be able to visualize this data. I want to be able to build a dashboard. So we have some tutorials that you can spin up yourself, and you can see how you can deploy data pipelines. We have all of the sample data and all of the steps kind of mapped out there, and then you can see how you can use that to build a dashboard using a readily available open source dashboarding tool. In this instance, it's Apache Superset. And so with Open Health Stack, which are the purple bits at the bottom, right? I just want to highlight here that these are used by developers to build standards-based solutions that leverage FHIR in some way, that are effectively powered by OHS, right? So OHS itself, it's not a competing solution. It's a set of building blocks that can also be used individually. So for example, you might just want to use the Android FHIR SDK, or you might just want to use FHIR data pipes, right? But you can actually also use them together, and when used together, you can start to see that they form a nice kind of backbone, if you like, for a new digital health solution. You can also use these in existing solutions as well. And something that comes up a lot is really, well, so when we talk about FHIR, does that mean, we have to change everything? And really, I'm not going to spend time on this slide today, but just to know that it's very important that we think about how we can integrate and really leverage, if you like, a kind of best of both worlds, right? If we have existing systems, we're very happy with those systems for certain purposes. We want to figure out ways of, as we're maybe transitioning to kind of more FHIR-based solutions, because we want to take advantage of that rich patient-level data, right, as opposed to maybe kind of collecting more aggregate data in the past. We can do this, and there's lots of different patterns. There are existing global goods. These are other kind of digital public goods, but there are ways to connect some of these systems up, and yeah, that could be a topic for another time. And so beyond the OHS, the technical components of OHS, we also provide developer resources, design guidelines, and we're working more on some of these other helpful tools, if you like. So looking at some of the advanced integrations and opportunities there. So our work with Open Health Stack has been a collaboration with the World Health Organization and a community of developers to really advance digital health and try to address this problem of how do we reach communities everywhere. So specifically with the WHO, Open Health Stack has been designed to enable the running of some of the smart guidelines content. So these are content packages that get published as implementation guides that contain all the logic and other things for delivering evidence-based care guidelines in computable formats. And so the Android FHIR SDK, for example, allows you to run that and deploy that into the field. And there really is a vibrant and diverse ecosystem that's kind of building together and supporting this as part of, that, as I said, that shift towards more kind of person-centric care, those kind of ideas embedded in that full stack approach to the future of global digital health. So we have technology partners who are adopting and building solutions using OHS, often working together with implementing partners who work with or on behalf of ministries of health, and supported by global institutions. And of course, our group is very involved with the FHIR community, and we kind of share lots of opportunities and try to work closely with that body, standard settings bodies as well. And something that obviously we get very excited about is seeing how these components are then working their way into different solutions that are being deployed in the field. So this is a map. Some of this is already a little bit out of date, and it's just kind of gives you a bit of a representation of where people are building and deploying solutions based on Open Health Stack. We also have some case studies that you can look at. If you take that QR code, it'll take you to that section of our developer site, and you can read some of those stories there. And something that we are really proud of is, we're really kind of at the beginnings of building a community that's really kind of working to catalyze the adoption of standards-based approaches, if you like, to digital health development. So we just came back to a week and a half ago or so. We were in Nairobi, Kenya. We were involved in coordinating and running this first Open Digital Health Summit that brought together 300 participants from 45 or so countries, and we had different technical tracks. So these were specifically trying to address some of the technical gaps, really kind of like leaning into understanding fire, understanding how to build with fire, how to use Open Health Stack and other components. There are other open technologies, other components out there that again, some of these you'll get introduced to if you come to the boot camp in February. But it's a very exciting, I think, movement. It's a very exciting time for global digital health, and we really hope that that you or people that you work with want to kind of get involved. And so there are many ways that you can get involved. You can first place to go is to the Open Health Stack developer site, which is just ohs.dev. If you're looking to contribute, there are ways to contribute. We're in the process of kicking off forums, and we'll be kind of encouraging people to take their conversations there. If you're a developer, you can join. We run like weekly developer calls. So one week is mobile, the next week is kind of server side. So if you just email that email address there, we'll send you access to the calendar and access to the invites as well. And we're also putting together training materials and things. So as people become more familiar with OHS, you might want to get involved in running a workshop, for example. So yeah, I hope that answers some of people's questions about what is Open Health Stack. If you want to learn more or get involved in the community, again, scan that QR code, please, and we look forward to hopefully welcoming you to the OHS community. And for those that are available in February, we will have a chance to meet in person if you can join the boot camp. So thank you very much.
Thank you very much, Sir Fred. Let me just share back my screen. Hold on. All right. I hope you can see my screen now. And we are opening the floor to question and answer. And I believe we have lots of questions in the chat box. Let me just read a few of them. Okay, so here's one. So this is from Sir, uh, hold on, Sir John. Um, Given the potential benefits for clinicians, is Google Health considering exploring AI-powered solutions or metadata standards that allow the use of common diseases names while maintaining compatibility with existing code systems? Like, for example, the use of type 2 diabetes instead of the code XR001, for example. And he believes that this could significantly lower the barrier to entry for healthcare providers and make adoption faster.
Sure. So thanks for the question. Is it John? Thanks, John. So first of all, there's no expectation that clinicians, particularly, or anybody really needs to learn or memorize these coding systems. So for example, if you have a look at something like SNOMED CT, or even ICD, I mean, most systems, you build, kind of like autocomplete solutions on top of that, that help you to find the right thing that you're looking for, and then it kind of maps that to the right code. I think so that's one thing just to point out. I mean, look, there's definitely a lot of interest in leveraging AI in coding in different ways and other things. And clearly, we are interested in how AI can help to address access to better quality healthcare. But specifically to this question, I think, again, I'm not sure if you've learned about the terminology service from CSIRO or Open Concept Lab, but a lot of these have very kind of intuitive ways of being able to find the right code that you're looking for. But I could imagine, in the future, there might be more like, ways of recommending, certain codes, kind of using, let's say, kind of some AI or some generative AI approach. But that still doesn't replace the need for these kind of terminology services, having kind of well-structured semantically represented data is going to be really important, even as AI and other opportunities present themselves.
Thank you so much. And I believe our very own SILab director, Dr. Alvin Marcelo, would like to add a few words to that question. Yes,
Sure.
go ahead, Doc Eli.
Thank you, Fred. Thank you, Gabby. Actually, this is one of the projects that we're setting up, Fred, in the SILab, where we're partnering with CSIRO, and we're offering Fire Lab, which contains onto server. It already has SNOMED development license, and we hope that the Department of Health can proceed next year with the procurement of the national license so that we can use it freely in the country. So that's something to watch out for, everyone. Once that subscription kicks in, then we can start using the resources of SNOMED and onto server for our production applications. Thank you, Fred. Back to you, Gabby.
Thank you, Dr. Alvin. Again, just reminding the group that you can ask your questions via the chat box. You can use the raise hand function if you want to unmute yourself, or you can type in at the Q&A button. All right. So there's another question regarding privacy. How do you ensure that only those general practitioners or nurses or other healthcare professionals treating the patients have the access to the data?
Yeah, that's a very important one. So the info gateway that I mentioned, that's a very important component in basically enforcing those access controls. So just to understand, you need to separate out the access control policies with the enforcement of those, right? Because one is an administrative and kind of operational, I suppose, set of activities, and then the other is maybe more technological. So in your scenario that you mentioned, like you would have in your system, you would have a way of defining some of those rules, right? So you would say, only the general practitioner or nurses who've been involved in this care or who sit within a particular location, something like that. So you would model that, and then that would be the rules. And then basically within the info gateway, you could define this access checker that I mentioned before. That's a kind of pluggable. So you would define your own access checker that would basically enforce those access control rules that you have basically defined. So that's something that's very important, something that you need to understand what those organizational rules are that you're trying to enforce, and then also how the data is structured on the FIRE side becomes important too. Right? So combination of things, but that's what the info gateway is there to make it easier to kind of enforce that in a kind of generic way.
Thank you, Sir Fred. Yes, Doc Alvin, you were raising your hand.
Yeah, thank you, Gabby. Fred, that means as together with the open health stack, as we build the community of practice around it, we should also come up with like a governance perspective
Yeah.
around open health stack so that we have a parallel and synchronous. As the technical people are working out the technical solutions, then the governance and management people are coming up with the right policies and are
Yeah.
making the right artifacts, policy artifacts, so to speak, so that the technology will have its accompanying circulars, for example, or administrative memoranda,
Yeah.
just to put things into perspective that the technology is important, but also the governance that
Yeah.
accompanies it well.
Absolutely. And maybe I'll just like maybe make sure that this point is clear. Like Open Health Stack is not a platform. And some people, I think, kind of sometimes it gets kind of like, it's like, oh, it's not like a software as a service or a platform that you use. I mean, it's a set of building blocks that you bake into different solutions. So, that doesn't mean that everybody has to go and build these things themselves, but you can if you want to. There are, growing kind of partners and others who have built different pieces, and you might want to, kind of leverage some of those, right? And so that's also kind of becoming part of the community and understanding where some of these are like solved problems that you might want to leverage, from groups that have maybe built solutions or have offerings that can be helpful too. Many of those can be open source as well. But yeah, just to understand, it's not a platform that has a defined, for a kind of defined problem. It's more building blocks that helps you to define, kind of a common set of problems.
Thank you so much for the clarification. With that, there's a question referring to the WHO slide earlier. Is there a um, component in the OHS that ensures interoperability across borders, such as different health regions or different national borders? Maybe someone's traveling, so such as semantics to be used, or value sets, or implementation guides, testings, or certification of tools.
So so what you're, I think, getting at is things like the International Patient Summary.
Yes, the
And
IPS.
what that's all about. So again, just to understand where that sits in the hierarchy of things, the International Patient Summary is an implementation guide, if you like. So it's part of the FHIR specification. Now, if you want to build an application that can, if you want to build like a mobile application, for example, you could build that on top of the Android FHIR SDK, and we have a little kind of IPS, demo where you can see how it can consume an IPS document, and then somebody can kind of carry that on their phone, and then they could potentially share that with somebody in a cross-border type of use case, right? But these things, back to Alvin's point, it's a lot of governance that needs to be thought through about these. IPS also defines some standard terminologies. So it uses the global patient, the SNOMED GPS. So some of those things are kind of are defined, but you still need to understand what different countries are going to be expecting and understanding. So so Open Health Stack can be a part of a solution there, but it isn't the whole solution. And there's a lot of governance and thinking that needs to kind of take coordination that needs to take place.
All right. Thank you. So there's another question. Actually, I'm not familiar with this, but will the Android SDK be available for Flutter? So it says Sir Thomas Reyes is a big fan of Google's development on Flutter and the cross-platform coverage. So are there any plans to extend the SDK to cover for that platform?
So with Android, I suppose with Open Health Stack at the moment, we have a native Android application. I mean, so the question is, I think, more about multi-platform support. So this is something that we do kind of get asked a fair bit. I mean, today it's very much focused on Android, and when we started, I suppose 4 years ago, the community was very clear that was what they were looking for, and I think still today there's far more kind of usage of Android. We are starting to think and try to think about some of the multi-platform opportunities. So, for example, there is now Kotlin multi-platform that we're interested to kind of look at, but we need to really understand like how much of a priority that is from the community. So join the community if that's something that you really want to see. Just to specifically address the question about Flutter. Flutter is a different language. There are some open source Flutter libraries. So there's a project called Flutter-Fly, F-L-I, that if you're really into Flutter, you can look at. It doesn't have the same kind of feature set as the Android FHIR SDK, but it does allow you to work at least with kind of questionnaires and that type of thing. So Flutter is not on our roadmap, potentially exploring something like Kotlin multi-platform, but it's not obvious. And then, if you're looking for Flutter, there are some existing open source libraries that you can check out.
Thank you so much for that. We have another question. So how did the successful countries implement Open Health Stack, and what were their key strategies, processes, and partnerships they used to ensure its effectiveness?
So I suppose that's more of a question for some of the implementing partners. But I think what we're seeing at the moment is, obviously FHIR needs to live within a kind of, a policy framework, right? So again, as Alvin mentioned, there's governance and other things. So what we don't necessarily want is just to be building digital health solutions on FHIR just because we can, right? So there's this kind of coordination. So the countries where I suppose this is starting to be adopted, and I'll say this hasn't been adopted and deployed nationwide I think most countries that we've been working in like sub-Saharan Africa, or our partners have been working in sub-Saharan Africa, South and Southeast Asia, are kind of at the early stages of this journey towards defining these national architectures where interoperability is becoming much more important, right? Because we've basically spent the last decade doing things that are not interoperable. And so now there's a big push towards that. This is where standards, fire and other standards have matured to a point where there's a lot more interest to try to adopt these international architectures. And then, then you need to be able to, or you want to kind of unlock the potential to be able to build solutions against that, right? So fire is a standard, and implementing the standard involves a lot of different governance and pieces to kind of come into fruition. But when that's in place, or where that's getting put in place, then I think you have a lot of opportunity to leverage things like Open Health Stack to make it easier to then show how you can build applications, interoperable applications against that standard.
All right. Thank you so much, sir. Maybe one last question. I saw Sonny raising his or her hand earlier. Maybe
Yeah,
he or she
yeah,
wants to unmute.
yeah. Hello, can you hear me?
Hello. Yes, we
Yeah,
can
there
hear you
was a question
clearly.
about Flutter. Just to add on to that, if he's working with Flutter, Flutter is basically a platform, so you can work with that with the Android SDK. It's been working for us. So just to add on to what was answered by Fred a while ago, so you can use it with the Android SDK.
Okay, Sunny, can you reach out to me after this? And I'd love to learn about how you've been doing that, what you've been doing with that.
Yeah, sure,
We'll have
sure, sure.
we'll have him in February, Fred.
I'll
I
attend
just
your
got my,
session in February. I will be in Manila. So
okay,
unfortunately, I'm in a different location right now.
okay,
So,
no
okay.
worries. My email address is in the chat. So anyway, if anybody
Yeah,
wants to reach out, please do. But yeah, Sunny would love to learn more
sure,
about that. Yeah,
sure, sure.
okay, great. So see, I learned something new today too, which has been great.
All right. So I think that's it. Thank you so much, everyone, for your valuable contributions. Thank you so much, Sir Fred. We've had some fantastic insights and questions from the group. Right. Okay. So there, Dr. Alvin preempted this one. Again, thank you so much, everyone, for joining our session. Uh, and I would just like to invite you all. So this session is just an introduction to Open Health Stack. And on January 15th, 2025, yes, that's next year, we will be having a deep dive topic on Open Health Stack. So I hope you guys scan the QR code flashed on the screen, or just check out our Facebook. We will be posting there the the link to this one as well. All right. So now, to receive your electronic certificates of participation, and before that, okay, so let me just again invite everyone to the Bootcamp Manila Digital Health Interoperability. So please scan the QR code flashed in your screen or use the bit.ly link. Anyway, we will be posting this as well on our social media pages. So please stay tuned for updates from our end.